It's easy to determine that some materials are mixtures because you can see their component parts. For example, if you pick up soil in your hand and look at it closely, you can make out that soil is made up of small rocks and decomposed animal and plant material. Milk, on the other hand, does not appear to be a mixture when it actually is, when milk is actually composed of fats, proteins, milk, sugar, and water. Milk is unlike soil because in order to see these components, you're going to have to look under a microscope. So now we can say that mixtures can be either a solution or a suspension. Starting with a solution, it is a homogeneous mixture of two or more substances in a single phase. Let's try to explain what a solution is by this simple experiment. So here we have water, and water is basically the solvent, which is the dissolving medium in the solution. Then I'm gonna put salt, or NaCl, and the salt is going to be the solute, meaning it's going to be the substance that is dissolved in the solution. When we mix sodium chloride with water molecules, all the salt molecules become uniformly distributed among the water molecules, and you can indicate that by the salty taste of any part of the mixture. And then later, all the visible traces of the solid salt are basically gone. And this is why you call it a homogeneous mixture, because you cannot distinguish its components by the naked eye. On the other hand, if the particles in a solvent are too large that they settle out, the mixture is then called a suspension. So also this time we're gonna put water, but then instead of salt we're gonna add sand or soil. Now, as you can see, the particles of the soil collect in the bottom of the cup. This is basically due to the fact that the soil particles are denser than the solvent, which is the water, and basically gravity pulls them down to the bottom of the container. These kind of mixtures are called heterogeneous mixture because you can visibly distinguish them from apart. Now, there are particles that are intermediate in size between solutions and suspensions, and these form mixtures called colloids. Let me demonstrate that to you. So we're going to put some water here, and then I'm gonna put coffee. So in the case of colloids, the particles in a colloid are small enough to be suspended throughout the solvent by the constant moving of surrounding molecules. But in this case, the particles make up the dispersed phase, and the water is the dispersing medium. Many colloids appear homogeneous because the individual particles cannot be seen, while the particles, however, are large enough to scatter light. This moves us to the last point we're going to discuss today. The Tyndall effect is a property that can be used to distinguish between a solution and a colloid. So we're going to try the Tyndall effect. So on the right we have the mixture of coffee and water, which is a colloid, and on the left we have the mixture of water and sodium chloride, which is a solution. We're gonna try it once on each before separated. So let's try it first on the colloid. We're gonna put it here, and as you can see, the colloid scatters the light. It clearly scatters the light. Now, if we try the Tyndall effect on water and sodium chloride, the water passes easily, like very easily, and you can see the water passing through it over here. When we try it on the other hand with the colloid again, it scatters the light everywhere. There isn't like a clear beam going through it. That's the difference. And that was all for today's video. I hope you enjoyed. Thank you.